The late June. Heat in Rahim Yarkhan was more than just weather. It felt like a physical weight pressing down on the entire city. Even in what Sareem jokingly called Sector Zero, his basement lab, the air was thick, heavy, and completely still. The oppressive heat seeped into the concrete walls like a slow, creeping poison. 2. It was 3 in the afternoon, and the power had already been out for 2 hours. Load shedding. Again. A familiar, frustrating rhythm of life. 20-year-old Sareem sat hunched over his cluttered workbench, sweat dripping from the tip of his nose and landing on a crumpled schematic. His soldering iron, a vital tool, lay dead and useless beside him, its tip cooling rapidly. Without electricity, it was little more than a metal stick. Anyone else in the city would be trying to nap through the worst of the heat or just complaining about it. But Sareem wasn't like anyone else. He was busy calculating dew points on a grease-stained notepad. 90% humidity, he muttered to himself, wiping his forehead with the back of his hand. 2. He looked around the soupy air of the basement. The air is basically soup, he thought aloud. Why are we thirsty when we're literally breathing water? It was a question that had obsessed him for months, a puzzle he was determined to solve. On the table before him sat the physical manifestation of that obsession. Project Oasis. To an outsider, it, though, probably looked like a chaotic mess, as if someone had fused a dehumidifier with the guts of 6 high-end gaming PCs, and then wrapped the whole thing in a layer of sheer desperation. At its core was a stack of 12 Peltier thermoelectric modules. These were small ceramic squares that had a fascinating property. When electricity passed through them, they could produce intense cold on one side and blistering heat on the other. Sareem had scavenged old chunky CPU heatsinks from dusty junk shops all over the city. He had then strapped loud high RPM server fans to them with a web of sturdy cable ties. An ESP32 microcontroller board, the brains of the operation, dangled from the side like a tiny cyborg brain, its small Wi-Fi antenna twitching expectantly. The idea behind Project Oasis was simple to explain, but brutally difficult to actually pull off. He wanted to extract pure, drinkable water directly from the humid air. And he wanted to do it with a solid-state device. No compressors, no moving parts like in a traditional fridge, and most importantly, at a low cost. It was precisely the kind of invention that commercial engineers and seasoned experts would dismiss as impracticable, wildly inefficient, or, their favorite, not viable in developing regions. But Sareem had never been very good at believing what other people claimed was impossible. In fact, those were the challenges he was drawn to the most. He was fueled by a stubborn belief that the limits set by others were merely suggestions, not rules. This whole project had started 3 months ago. After a particularly brutal heatwave had left the city's water supply strained and unreliable, he'd seen neighbors rationing water, the lines at the community taps growing longer and more tense each day. The sight had ignited something in him. It wasn't just an engineering problem anymore, it was a mission. He pored over online forums, downloaded research papers, and watched countless hours of tutorials, absorbing everything he could about thermodynamics and atmospheric water generation. The first prototype, Oasis Mark I, had been a spectacular failure. It had managed to produce a few measly drops of water after running for an hour, all while consuming a huge amount of power and nearly setting his workbench on fire. Mark II was slightly better, yielding about a cup of water, but it was still nowhere near the efficiency he was aiming for. This current version, Mark III, was his most ambitious yet. He'd refined the design, optimized the airflow, and written more sophisticated code to manage the Peltier modules. But now, sitting in the dark, powerless basement, his progress had ground to a halt. He stared at the lifeless machine. The heat was a constant, mocking presence. His mind, however, kept working. He sketched out a new idea on his notepad. A small, rechargeable battery system. Maybe he could salvage some old laptop batteries, string them together, and create a power bank that could run the device for at least a few hours during these blackouts. It would be just enough to prove the concept worked, even when the city's grid failed. The thought energized him. The power outage wasn't just an obstacle. It was part of the problem he was trying to solve. This device needed to work for people in these exact conditions when infrastructure was unreliable and resources were scarce. He stood up, a new sense of purpose cutting through the lethargy of the heat. He knew where he could find old laptop batteries. The junk shop owner, Mr. Bashir, owed him a favor. As he made his way up the stairs and out of the cool darkness of the basement, the wall of heat hit him with full force. The sun was a white-hot disk in a hazy sky. The streets were unusually quiet, the city conserving its energy. But Sarim walked with a quick, determined stride. He wasn't just a kid tinkering in a basement anymore. He was an inventor on a quest. Chasing a vision of a world where a glass of clean water could be pulled from the very air we breathe. And in a city gasping from thirst, that was a vision worth fighting for. One salvaged battery and one line of code at a time. The heat could press down all it wanted, but it couldn't stop an idea whose time had come. It's a story about ingenuity, desperation, and the power of a single idea. Imagine this. You're in a city suffocating under an intense heat wave. The power is out, the taps are running dry, and the air is thick and heavy. There. This is the reality for Sarim, our protagonist, a tinkerer working away in the quiet solitude of his basement. His world is lit by the dim glow of his laptop, powered by a UPS, that familiar, beloved lifeline for anyone who's ever tried to get work done during a power outage in Pakistan. He glances at the battery display. 30%, he says to himself. It's not much, but it might be just enough for one crucial high-stakes test. Takes a deep breath and connects a set of thick jumper cables from the UPS directly to his machine. You can almost hear the battery groaning under the sudden, heavy load. Sarim's fingers fly across the keyboard. He's flashing new firmware onto an ESP32 microcontroller, the tiny brain of his operation. Suddenly, the silence of the basement is shattered. A set of fans roars to life. Their noise, feeling almost comically loud in the stillness. On his screen, numbers flicker and dance. The cold side temperature is dropping fast, 15 degrees Celsius. Then 10. Then 4. But there's a problem. The amperage draw is climbing just as quickly, hitting 18 amps. That's critical territory. Come on, he whispers to the machine. Don't melt the MOSFETs. He can feel the heat radiating from the custom power board he built just last week. The copper lines, heat painstakingly etched by hand, are now glowing, doing a very convincing impression of a toaster oven. And that's the real challenge here. Making something cold with Peltier tiles is the easy part. The hard part, the part that separates success from a smoldering pile of electronics, is managing the immense waste heat. If the hot side gets too hot, all that heat just bleeds right back to the cold side. Your supercooler becomes a superheater. And the experiment is over. Sarim knew he needed a smarter solution. He couldn't just blast the heat sinks with air. He needed something more dynamic. An idea sparks. He starts typing again, adding a new block of code to his firmware. He's implementing an oscillating PWM pattern for the fans. Instead of a constant, steady drone, the fans will now pulse, feel shift in rapid cycles, creating tiny, turbulent vortices of air that dance over the heat sinks, pulling heat away more efficiently. The sound in the basement changes. The steady roar is replaced by a rhythmic pulse. Hump, hump, hump. It sounds like a slow, mechanical heartbeat, a testament to the life he's trying to breathe into this contraption. He watches his laptop screen with bated breath. It's working, hot side temperature, which was dangerously climbing, begins to stabilize. And the cold side, it plummets, dropping below zero. A thin, delicate layer of frost starts to form on the machine's aluminum fins. You might think frost is a good sign, right? Cold means ice. But for Sareem, it's a disaster. No, not ice, he groans. Ice is an insulator. It would coat the surface and completely kill the efficiency of his condensation process. He doesn't need a frozen blot. He needs a cold, metallic surface, precisely calibrated to be just above 0 degrees Celsius. He needs to hit the exact dew point, the magical temperature at which the moisture in the air will turn back into liquid water. He goes back to the code, tweaking parameters, adjusting fan speeds, and fine-tuning the power delivery. He watches as the frost recedes, thinning out until it's just a shimmer on the metal. If a temperature holds steady, hovering right where he wants it. Now, all he can do is wait. The minutes stretch on, feeling like hours. The only sound is the rhythmic pulse of the fans and the frantic beating of his own heart. And then he hears it. A soft, almost unbelievable sound. Tink, a single. Perfect drop of water falls from his machine into a clean glass beaker he had placed underneath. Sareem freezes, barely daring to breathe. Tink, 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 the rhythm picks up, getting faster and more confident. It's real. It's actually happening. Clean, liquid water is running down the supercooled fins of his device and dripping, drop by precious drop, into the beaker. He leans back in his chair, a wave of relief and disbelief washing over him. His heart is pounding in his chest. Think about the context here. He's in a city where people are desperate for water, where the municipal supply is failing. In his basement, using scavenged computer parts and a bit of code. He is literally pulling clean, fresh water out of thin air. He watches, mesmerized, as the beaker slowly begins to fill. Each drop that falls feels like a monumental victory, a tiny rebellion against the oppressive heat and scarcity outside. This isn't just an engineering project anymore. It's a lifeline. It's proof that with a little knowledge and a lot of determination, you can find solutions to even the most daunting problems. 30 minutes later, the dream is interrupted by a frantic, high-pitched beeping. It's the UPS. It's final. Desperate cry for help before the battery dies completely. Sareem acts fast, yanking the jumper cables out. And at that exact moment, as if staged for dramatic effect, the main power grid kicks back in. The basement lights flicker on, bathing the room in a harsh, bright light. The sudden silence is deafening. The rhythmic pulsing of the fans is gone. All that remains is the quiet hum of the now recharging ups and the gentle, steady drip of water into the beaker. Sareem looks at the beaker, now a quarter full of clear, clean water. He created this. From nothing but air, electricity, and an idea. It's a powerful reminder that sometimes the biggest breakthroughs don't come from massive labs or corporations. They come from a single person, in a basement, refusing to accept the world as it is and determined to build a better one drop at a time. What Sareem achieved is a real-world application of thermoelectric cooling, often seen in portable coolers or high-end computer CPUs. By creating a significant temperature difference, he forced the water vapor in the humid air to condense, just like how water droplets form on the outside of a cold glass on a summer day. His clever use of pulsed fans to manage thermal runaway is a brilliant piece of practical engineering. It's stories like this that inspire us. It shows that the tools to change the world are often closer than we think. Thank you so much for joining me for this incredible story. What do you think? Could this technology be scaled up to help solve water shortages? Don't forget to like, subscribe, and hit that notification bell. He lifted the beaker, watching about 300 milliliters of clear, cold water slosh inside. It was real. Drinkable. Just then, he heard the familiar creak of the basement door opening. Billy descended the stairs, looking like the heat had personally attacked her. She was fanning herself with a notebook. "Sareem, I swear I'm going to melt," she said. "Mum said you were down here cooking something. It smells like hot ozone." Her eyes landed on the strange device humming on his table. "What is the Death Monster 3000 doing today?" "It's not a death monster," Sareem said, feeling exhausted but grinning from ear to ear. "It's a hydration solution." He held up the beaker as proof. Billy blinked, confused. "Where did you get cold water?" "The fridge died 2 hours ago." "From the air," he said proudly. He pointed at the machine, which was still sweating rivulets of warm condensation onto the workbench. It's atmospheric extraction. Solid state, no compressors. Almost all recycled parts. Billy approached slowly, suspicion written all over her face. She took the beaker from him, sniffed the water, then took a small, cautious sip. Her face immediately lit up. "It tastes clean." Without another word, she downed the entire thing. "Sareem, do you have any idea how many village Isaac, even parts of Rahim Yarkan have brackish groundwater? If you could scale this up, make it run off solar." "Already planning that." Sareem interrupted, spinning back toward his computer. "But the current draw is too high. Silicon transistors just aren't efficient enough. I need to redesign the entire switching system using gallium nitride. That'll give me better thermal output and lower power loss. And I want to try hydrophobic surface texturing on the fins to channel the water faster." Billy laughed, shaking her head. "You're ridiculous," she said fondly. "Come upstairs. You look like a dehydrated raisin. And your mum thinks you've electrocuted yourself." Sareem hesitated. He had just had another idea. Maybe a honeycomb airflow shroud could improve turbulence and reduce thermal soaking. But Billy grabbed the back of his chair and rolled him away from the screen. "No more tech talk until you drink actual water," she ordered. He grinned sheepishly and followed her up the stairs. Upstairs, the heat felt even worse. The sun glared through the windows like a physical weapon, making Sareem squint as he stepped into the living room. His mother fussed over him immediately. "Beda, you were in that basement for so long. At least drink something." Sareem lifted the empty beaker. "Already did." Billy quickly interjected, from his science thingy. "Don't worry, he didn't blow himself up." "Oh." His mother sighed, as if this was not reassuring at all. Sareem sat on the sofa, letting his heartbeat slow down. His body still felt warm from the machine's waste heat radiating in the small basement. Billy sat beside him, twirling the empty beaker in her hands. "So, what now?" she asked. Sareem stared at the ceiling fan, spinning lazily, barely stirring the thick, hot air. Oasis works. It's small scale, but it works. The next step is energy efficiency. Billy leaned forward, her earlier exhaustion replaced by a spark of excitement. "So, the gallium, what's it called?" "That's the key." "Gallium nitride," Sareem read. "It's a semiconductor. It can handle higher voltages and temperatures than silicon. Which means I can build a smaller, more powerful, and more efficient power system. The current design is like trying to power a sports car with a lawnmower engine. It works, but it's wasteful." "Where do you even get that stuff?" she asked. Sareem shrugged. "I've some salvaged components, but to really build it right, I'll need to order new chips. They're not cheap. And then there's the programming. The control logic for GaN transistors is way more complex. I need to make sure the switching frequency is perfect to maximize water output without frying the whole system." He looked back at the basement door. his mind already racing through schematics and code. 2. The real challenge isn't just making one that works. It's making one that's cheap enough for people to actually use. Recycled parts are great for a prototype, but for a real product, it needs to be reliable, easy to manufacture, and affordable. He pictured his device, not on his messy workbench, but sitting outside a small home, quietly pulling clean water from the humid air, powered by a simple solar panel. Billy put a hand on his shoulder, snapping him out of his thoughts. One step at a time. Genius. First, let's survive this heat wave. Then we can figure out how to save the world. She stood up and headed to the kitchen. I'm going to see if your mom has any of those frozen fruit bars left. You want one? Sareem nodded, a smile spreading across his face. For the first time all day, he wasn't thinking about Peltier modules or thermal dynamics. He was just thinking about a cold fruit bar. But as he sat there, he knew this was just the beginning. The proof of concept was a success. Now, the real work began. First, the world was thirsty, and he was pretty sure he had just found the well. This story, friends, is a powerful reminder that innovation often starts not in a high-tech lab, but in a basement, driven by a simple need. Sareem's Oasis is more than just a clever machine. It's a symbol of hope. It shows us how one person's passion and ingenuity can tackle some of the world's biggest problems, like water scarcity. Think about it. A device that creates clean drinking water out of thin air, using minimal energy. This sounds like science fiction, but the technologies Sareem talks about, gallium, nitride, solid-state cooling, are very real. This is what drives progress. It's the refusal to accept that a problem is too big to solve. Sareem saw a problem: no cold water during a power outage. His mind immediately jumped to a global solution. He didn't just want to fix his own thirst. He wanted to help entire communities. His basement wasn't just a workshop. It was a launchpad for an idea that could change millions of lives. 2. What I love most is the dynamic between Sareem and Billy. He's the brilliant, hyper-focused inventor, lost in the world of transistors and thermal efficiency. She's the practical, grounded friend who pulls him back to reality, reminding him to take care of himself while also being the first to see the massive potential in his work. She's his first believer, his first user, and his connection to the very people his invention is meant to help. Every inventor needs a Billy, someone who can translate the technical jargon into a world-changing vision. And let's not forget the core of the story, the power of a single idea. It all started with a simple question: how can we get water? From there, it spiraled into a project involving advanced materials, power efficiency, and scalable design. This is the journey of every great invention. It begins with a spark of curiosity and is fueled by relentless problem-solving. Sareem's path won't be easy. Faces challenges with cost, efficiency, and scaling up. But with his determination and a supportive friend by his side, the possibility of turning his Death Monster 3000 into a life-giving oasis feels incredibly real. This story is an inspiration for anyone who has ever had a crazy idea. It tells us to keep tinkering, keep questioning, and keep building. Your basement project might just hold the solution to a problem you haven't even realized the world is facing. If you enjoyed this story and the ideas behind it, don't forget to like, share. Can't rely on UPS forever. I know. He leaned forward, his excitement bubbling up again. But just imagine a solar-powered version. Cheap, portable, ... One single unit could supply clean water to an entire household. Billy gave him a gentle nudge. You mean one unit could make you famous? Sareem snorted. That's the least important part. Maybe, she said quietly, but sometimes fame is what attracts funding. That stopped him in his tracks. He knew she was right, but the thought still felt uncomfortable. A week passed. Sleep became a luxury Sareem couldn't afford. The power cuts grew longer with each passing day, stretching into the night. The heat wave intensified, clinging to everything. Rahim. Yarkon was known for its brutal summers, but this year was on another level. Their neighborhood WhatsApp group was a constant stream of desperation. Water pressure is low again. Skip the bath today, the tank is half empty. Does anyone have a spare bottle of water for my kid? Each message was a stark reminder of why he was doing this. So Sareem kept tinkering. 2. Redesigned the airflow casing using cardboard mock-ups, piecing them together like a puzzle. He rebuilt the power board, this time using white copper tracers to handle the load better. He managed to get his hands on 2 newer, faster Peltier modules, and carefully replaced the old ones. Through it all, Billy was his anchor. She diligently recorded temperature readings, her handwriting neat and precise. She collected water samples in small vials, labeling each one. Every tiny improvement felt like a victory, increasing the output by just a little bit. A few more milliliters per hour hit, a few precious watts saved there. It was all incremental progress. But Sareem knew, deep down, that something was missing. He needed a breakthrough, a quantum leap, not just these small steps. One sweltering night, the darkness of a blackout pressed in on them. Billy sat on the cool basement floor, sketching ideas in a notebook by the light of her phone. Sareem was rummaging through a box of wires, his frustration mounting. "We need to think like nature," she said suddenly, her voice cutting through the silence. Sareem paused and glanced over at her. "What do you mean?" "Look at how do forms in deserts," she explained, her eyes bright with inspiration. "Think about the fog nets in Chile, or even spider webs. The surfaces that gather water best aren't flat. They're hydrophobic in some places, hydrophilic in others. It's a combination." Serene's eyes widened slowly as the idea took root. "That's it," he whispered, the words barely audible. "Surface geometry." He dropped the bundle of wires with a clatter and lunged for his own notebook. "The condensation surface area isn't the limit, it's the path the water travels across the surface. Smooth aluminum causes droplet adhesion. The water just sticks there. But if I etch microgrooves, maybe with a Dremel or bi-sandblasting, I can create channels. I can force the runoff to accelerate." Billy leaned back, a satisfied smile on her face. "You're welcome." Sareem didn't even hear her. Who's already lost in his own world, frantically drawing complex fin structures. Envisioning each tiny channel guiding a droplet of water toward the collector. This was it. This was the breakthrough he'd been waiting for. 3 days later, Project Oasis 2.0 stood proudly on the workbench. It looked different, more refined. The heat sinks now shimmered with the tiny, precise lines he had painstakingly etched into them. The fans were housed inside a rough, but functional, 3D-printed shroud that Billy had designed on her laptop. She had found a local community center with a printer and spent hours there, printing it in 4 separate sections that they later assembled. It was a testament to their partnership. With a deep breath, Sareem connected the final wires. The uninterruptible power supply hummed to life. The fans engaged. There were a sound of promise. He watched the monitor, his heart pounding. The cold side temperature began to drop, steadily, faster than ever before. This was it. This was the moment. He lowered over at Billy, a wide grin spreading across his face. Her smile mirrored his own. They had done it together. Few were inspired by Sareem and Billy's ingenuity and perseverance. Continue watching. This time, there was no frost. Just a thin, beautiful sheen of moisture racing along the textured fins, straight into the drip channel. I couldn't believe my eyes. Within minutes, water started to flow. And I don't mean just drops like before. This was a thin, continuous trickle. A steady stream of pure, clean water. Beside me, Billy gasped. I think I forgot to breathe altogether. We watched as the beaker filled up. And get this, it took half the time as our last test to collect almost the same amount of water. I leaned back, absolutely stunned. I looked at Billy and just said, "Billy, you are a genius." Shikar. This huge grin on her face. "I accept payment in biryanis," she joked. We were on top of the world. Our invention, Oasis, was working better than we could have ever imagined. But we had no idea that its real test was coming, and it was coming a lot sooner than we thought. Just 2 nights later, chaos erupted in our neighborhood. I woke up to frantic shouts outside. People were panicking. The water tankers, the ones our whole community depends on, had failed to show up. To make things 100 times worse, the local supply line had been contaminated. There was this brackish backflow from some nearby agricultural land, and whatever was coming out of the taps was just unusable. It was a nightmare scenario. My mum knocked on my bedroom door, her voice filled with worry. "Beta," she said, using the affectionate term for son. "We don't have any drinking water. Can you check the filter?" Maybe it's just clogged. I knew it wasn't the filter. I had seen the brown, murky water coming from the taps myself. My heart started pounding in my chest. My eyes darted over to the corner of my room, where Oasis sat. Billy was still there. She'd stay late to help me run some final tests. Our eyes met across the room. She knew what I was thinking. "Sareem," she whispered, "we could use it." A wave of hesitation washed over me. Oasis was still just a prototype. It was unstable, it used a ton of power, and we had never run it for a long period of time. It was a huge risk, slow. But then I looked at the worried faces of my family, the fear in my mother's eyes, and I knew I had to try. The decision was made. Together, Billy and I carefully carried Oasis upstairs. It was heavier than it looked. We lugged the big, uninterruptible power supply, the UPS, right behind it. I found the perfect spot, right next to an open window to maximize the airflow, which was crucial for the machine to work. I took a deep breath and flipped the switch. The entire house filled with this deep, rhythmic hum from the machine's oscillating fans. It was a sound of hope, but also a sound of uncertainty. My mother watched us, her expression a mix of nervousness and desperation. Billy stood right beside me, her hands clasped tightly together. It felt like the whole world was holding its breath. The minutes ticked by, each one feeling like an hour. The humming continued, a constant reminder of what was at stake. And then we heard it. Tink, a single drop. Tink, tink, a few more. And then a trickle. A steady, beautiful trickle of clean water started flowing into the beaker we had placed underneath. It was working. It was actually working. Holiday. I carefully took the first cup of water we collected and handed it to my mother. She took it, her hands slightly trembling. She looked at the water, then at me, then back at the water. She took a sip, hesitant at first. Jet. And then a look of pure relief washed over her face. "It's cold," she said softly, her voice filled with wonder. "It's clean." Word spread through our building like wildfire. Neighbors started knocking on our door, holding empty bottles and containers, their faces a mixture of hope and skepticism. One by one, we filled them. A young couple with a newborn baby got the next few liters. An elderly man who lived alone on the top floor came down, and we made sure his jug was full. The look of gratitude on their faces was something I will never forget. Oasis, our little prototype, hummed away all night long, a beacon in the darkness. It wasn't just a machine anymore, it was a lifeline. Billy and I stayed up, monitoring its performance, swapping out filled containers for empty ones. We were exhausted, but we were running on pure adrenaline. We were actually making a difference. We were providing clean drinking water when there was none. By sunrise, Oasis had produced over 50 liters of water. It was enough for our immediate neighbors, enough to get them through the worst of the crisis. Looking at the line of empty containers that were now full, I realized this was bigger than just a science project. This was about community, about helping each other in a time of need. When the new water tankers finally arrived the next afternoon, the crisis was over. But for our small community, something had changed. They didn't just see me as the quiet kid who tinkered with electronics anymore. And they saw Billy as a hero. Shit. They looked at Oasis with a sense of awe. That night, our little prototype hadn't just made water. It had created a bond, a shared experience that brought us all closer together. As I finally powered down the machine, its rhythmic hum fading into silence, I looked at Billy. We were both covered in grease and completely drained, but we were smiling. "Biryana are on me," I told her, "as many as you want." She laughed, a tired but happy sound. That night, in the face of a real crisis, our invention had not only worked, it had brought hope. And we knew, with absolute certainty, that this was just the beginning for Oasis. We had a long journey ahead, but now, we knew our creation had the power to change lives. And we were ready to take it to the world. Sunbed listened, and the news spread like wildfire. A neighbor knocked on the door, their voice strained with desperation, just hoping for a single bottle. Then another came, and another. Before they knew it, a small line of people had formed outside their home. A quiet, hopeful queue, dozens of them seeking the one thing they couldn't find: clean water. Reem looked at the crowd, his heart aching. He knew Oasis, in its current state, couldn't possibly serve everyone. It was just a small prototype, never intended for this scale. But even giving a few liters felt like a victory against the relentless heat. The very next day, a local reporter appeared, microphone in hand. "Is it true?" she asked, her eyes wide with a mix of skepticism and wonder. "Holly really built a machine that creates water right out of thin air." Sareem was speechless, completely caught off guard. The words just wouldn't come. That's when Billy stepped forward, calm and collected. "It's just a prototype," she exclaimed. "But yes, it works." And just like that, the story exploded. It started with a few small tech blogs, little corners of the internet buzzing with excitement. Then, regional news stations picked it up. Soon, a major national outlet was on the phone, asking for an interview. Kareem found himself sitting in his basement, the familiar hum of Oasis, a quiet comfort beside him. He felt completely overwhelmed, the sudden attention a tidal wave he wasn't prepared for. Billy gently nudged him, sensing his unease. "Hey," she said softly, "fame doesn't matter, right?" Sareem took a deep breath. "It doesn't," he agreed, his voice barely a whisper. "But funding does." A smile spread across Billy's face. "Then let the world see it," she said, her voice full of conviction. "Let 'em see your bug fix for water scarcity." A month later, everything had changed, with the incredible support of a local university and a startup accelerator. Sareem and Billy transformed their prototype into something truly powerful. Oasis 3.0 was born. It was sleek, solar-powered, and astonishingly efficient. It could generate several liters of clean, fresh water every single day. Even under the punishing glare of the extreme desert heat. They chose the perfect spot for its debut, a neighborhood on the very edge of the city, a place where the groundwater had turned salty and unusable years ago. The day of the installation was unforgettable. A crowd of children gathered, their eyes wide with fascination, as they watched the machine come to life. They stared, mesmerized, as the first clear, clean drops of water began to drip steadily into the waiting containers. Sarim stood by, his hand resting on the smooth, cool metal of the machine he had built from nothing more than scrap parts and a stubborn, unyielding hope. He was silent, just taking it all in. Billy nudged him again, a proud grin on her face. "You did it." Sarim looked from the machine to the children, then to Billy, and a slow smile spread across his own face. "We did it," he corrected her. Above them, the sky over Rahim Yarkon shimmered with the intense, familiar heat. But for the first time in a very long time, the air didn't feel suffocating. It didn't feel like a heavy blanket of despair. For the first time, the air felt like possibility. Felt like the future. This story isn't just about a machine. It's a powerful reminder that innovation often starts not in a high-tech lab, but in a basement, driven by a personal need and a refusal to accept the status quo. Sarim and Billy saw a problem that affected their entire community. A bug in their world, and they dedicated themselves to finding a fix. Their journey shows that one person's idea, fueled by passion and collaboration, can ripple outwards and bring about real, tangible change. It proves that even the most overwhelming challenges, like water scarcity, can be tackled with ingenuity and hope. What bugs do you see in the world around you? What problems do you wish you could solve? Sometimes, the most profound solutions start with a simple question. What if? Let us know your thoughts in the comments below. We'd love to hear what inspires you. If you enjoyed this video and want to see more content just like it, do me a huge favor and smash that subscribe button. And don't forget to ring that little notification bell next to it. Bye for now. See you soon.